Hello. So my name is Rivo, and I'm going to talk about how we changed logging in Veriff, specifically how we started using structured logging, and then some takeaways and lessons we learned during that. But let's do a quick show of hands first. Who here is at least slightly familiar with what structured logging is or how it works? Just a few. Anyone using it in production? All right. Looks like I can teach something new to most of you. So, quick introduction about who I am. I joined Veriff about 1 year ago. I'm part of the automation team. And while most of the automation team has rather data science background, then I lean towards a more traditional software engineering, which means that I'm often working on platform level stuff. And that includes also this logging overhaul. Pete already did introduce our project, but a very quick refresher is that you follow some instructions, you take a selfie image, you take some images of the document you've got, then we might also ask for an image of you with your document, and then the verification process begins. And in case of automation, that means that we basically run a whole bunch of services that will take a look at those images and the verification session in general, and we try to figure out what's going on there. Now, I will be using this extremely simplified version of face detection service for the presentation. If you have problems reading this, then I will be using lots of code in this presentation, and there are some seats in front here. So feel free to move up. But basically, as you can see, we download an image from S3, we run it through some face recognition algorithm and get the results, and then save those through our internal API. If we try looking at what this service logs right now, then obviously nothing, because we haven't added any logging yet. So let's fix this and add a bit of logs that say that we are processing this upload with this ID. And now we can see something. I already mentioned that we've got different types of images, so let's include that information in the logs as well. And it might also make sense to log out how many faces we found on this image. So now we're already getting somewhere. And this is roughly how the automation services looked like about half a year ago. We had about 15 microservices doing various things like face detection, figuring out if the face on the document image and the selfie face are those of the same person. We would try to read out all the text from the document images, and we would then figure out which of those words that we read out is your first name. And this meant that they are all sort of collaborating or working on the same data, like the same verification or the same image. And that also meant that if something went wrong, then we didn't often know what service the problem originates from. Is it that we couldn't read out any text? Is it that we couldn't figure out which of those words is the first name? We had to figure that out. And that means that we had to do a lot of searching by upload IDs, for example. We use AWS CloudWatch for log storage, and CloudWatch lets you write those simple queries. So in this case, we're searching for log messages where the message itself contains the particular ID. And this kind of gives us what we want. But as you can see, it's a full text search that just uses substring matching. And this comes with its own problems. Let me go back. And you can see that we do find the processing upload message, but we don't find the message saying how many faces we found, because we didn't include the upload ID in that one. Also, if we tried searching for all the logs about face images, then we do find what we want, and then we also find something that we don't really want, because it also happened to include the same word. So going back to our code example, one way of fixing it would be just put quotation marks around all the dynamic values, like this, and then also include the upload ID in the second message. And that kind of does work. We can then search for a face with the quotation marks around it. But this comes with a lot of assumptions, and as you can already see, this is quite fragile because the developers need to keep in mind that they need to add those quotes there, they need to use this particular type of quote, and also basically we're putting a lot of mental pressure on developers. And if something goes wrong, then at some point you're like, yeah, I'll just use regular expressions, and that's not the way you want to be going down. So I hope I convinced you by now that just logging out text or prose is not very good. It's easy to do. As humans, we're quite used to it. But it's difficult as soon as you start doing something on those logs with machines, like searching. And as mentioned, it comes at mental cost for developers. So let's look at one better way, which is structured logging. And the whole core idea of structured logging is that we log data instead of just text. And as you know, data is already machine readable, which gets us around quite a few of the problems we already saw. So let's once again go into code examples. And this is a traditional logging call where we just create a message and then embed some data within that message. With structured logging, instead of a single message, we would be dealing with an event describing what is happening, or like the type of the event that is happening, in this case process upload, and then we add some additional context to it to describe this event in more detail. In this case, we're including the upload's ID as well as the type. And then usually you end up outputting and storing those logs in some structured format, like in this case, the JSON. And also the logging library itself can add additional information like the timestamp in this case. Now, JSON is not the most human-readable format, so for this presentation, I will be using this simple text-based format instead. But always keep in mind that the data we're dealing with is actually structured and not text behind the scenes. One important thing that structured logging allows you to do is separate the event from gathering the context. So in this case, you can see that we start by binding certain data, certain attributes to the logger itself, and then later we will log out the event, the same process upload, and that means that the data we bound to the logger earlier will be included in the log event the same way as earlier. So the output is the same, but the important pattern that this lets you do is basically gather the context iteratively over time as it becomes available. So we might start by binding just the upload ID. Then as soon as we figure out what the type of the upload is, we bind that one as well, and so on and so forth. And then in the end, log out the message itself. So let's go back to our code example, which looked like this with traditional logging, and convert it to structured logging and have a little walkthrough here. As I already explained, we first start by binding the upload ID to the logger, which means that now every single log message or event that we log out will be guaranteed to have this upload ID. So the developer will no longer need to ensure that this upload ID is included everywhere. It happens automatically. Yes?
This would work when you pass context through the execution chain within the same process. But what if your process is actually distributed and asynchronous? How would you pass context then all the way down where it's actually locked?
I guess that would mean that you would need to pass that same context to the other process that is doing the, processing and somehow coordinate. But yes, you're right that...
Then it becomes kind of not nice. If you imagine code doing this, then
I'm not sure how many cases there are where you have the exact same operation essentially being done in different processes.
I'll give you an example. A customer initiates deposit, then it gets redirected to the payment provider, and then it does something on a payment provider, and then you receive callback from the payment provider to a different process.
Okay, so in this case we're already talking about distributed tracing essentially, and I will shortly talk about that later.
All right, thank you.
Sure. So continuing with this example, we then log out two events, the process upload and the faces found. And you can also see that we can add additional context that is specific to those events. So for the process upload, we will include the uploads type, and for the faces found, we include the count. And then our CloudWatch query becomes really straightforward. We just say that we want to find all the entries where type equals face, and then that is exactly what we will get without any false positives. So now that you have hopefully some idea of what structured logging looks like, let's go a bit deeper and compare it to the more traditional approaches, and also look at the whys and assumptions between both of them. So with traditional logging, I suppose one of the assumptions is that you have just one service, or perhaps a small number of services. This means that if anything happens and you need to start investigating it, you already know where to look. And it also usually means that you have relatively small number of log events. So you can just go and look at those raw log events without any additional processing. And so the raw log entries in this case are consumed by humans by just looking at them with your eyeballs. And because we are quite used to consuming text, then we also try to make our log entries look like an average text, which means keeping the line length down to a reasonable level. And if it gets too long, we often split that log entry into multiple ones. Today, though, we are dealing often with slightly different systems, ones that are distributed and use, for example, microservice architecture, and you can have tens or hundreds or even thousands of different services which make up the system. And as I previously explained our automation use case, it means that any incident response is usually not limited to a single service, and it starts by you not knowing where the problem is. And because all of those services generate quite large amounts of log data, you will absolutely need to have some sort of searching or filtering. It also means that you might want to, instead of consuming the logs as text, do something more novel with them, like graphing them, for example. So you might want to count the number of log entries per minute. And if those log entries are about requests made to some API, then essentially you get a graph of the number of requests made over time, which can help you pinpoint where the problem lies. And this means that the raw log entries are not consumed by us anymore. Instead, they are rather first processed by some system, and then we sort of use the processed or derived results. And as a result, we can also include lots more context with each of those events. So let's get into a bit more detail on that one. As said, we basically have this mindset change where we go from text logs to events and contexts. Events being something that is going on, like internal API request made or some upload being processed. And then context is additional descriptive data that helps us figure out what exactly was happening. And I have an example about some random API request being made. And with traditional logging, we might want to log the path or URL of the request, the HTTP method, the response code, maybe also how long it took. And then that line is already quite long, so we probably wouldn't include much more. We could do the same with structured logging, but we can also add lots more detail here, like how big was the response that we received, or what were the upload and verification IDs that we were working with at that time. And we can go much further and also include some information about the environment and application, like is it production or staging environment, what is the exact version of the application, and what is the commit hash of the source code that the application or service was built from. And this might seem like perhaps a bit too much data, but one day when you will discover that this particular incident you're working with was caused by, for example, a particular version of a service making too many API requests, then this will be quite valuable. Going on, we have also created a sort of internal Python package, because Python is what we use in automation team mostly, that basically adds some helpers and other ideas to the more standard or straightforward structured logging. So let's walk through those. First of all, we have some helper functions that let you add timing information to the logs. For example, we had that face detection service example when we first downloaded the image, then ran the face detection algorithm, and then saved the result. And we could add timing information about all three of those events. We also use Sentry for error reporting. So we have a Sentry integration which also makes sure that all this additional context that we are gathering anyway makes it to Sentry. Then we have another type of context called global context, which goes back to the idea of wanting to add certain information to all log entries, like the upload ID in this case. In this case, it works because we're dealing with one single function or one single logger. But this might break down if we're using some external package that uses a different logger that does not have that information bound to it. Or we might use some package which does not use structured logging at all and uses Python's standard library logging. And we wanted both of those cases to be covered, so we wanted to always get that upload ID in this case. And then we added some additional integration to make that happen. We also make use of something called canonical context, which is essentially a summary of what is going on. And the idea is that we might have some data spread across different log events. In our example, we had the type being added to one log event and the number of faces found added to another. But if we now wanted to search for, let's say, face images where we didn't detect anything, then we would have to somehow make that happen across multiple log entries. And the solution here is to create this canonical or like summary log entry, which includes all the important context. And then we can very easily just query that in CloudWatch or similar service.
Is canonical created automatically, or you just once more you log everything?
In our system, you say that I want this binding to be canonical, basically. So it works on the developer level. The developer says that this is important data that should be included in canonical log.
i.e. manually.
But then you can also do the query, like saying like this thing or this thing, and then assemble it all together.
Yeah, but then you have to assemble it. And it's kind of an ergonomic feature, so it basically gets around the assembly. I wouldn't say it's premature, because it has given us quite useful use cases. For example, it gives us metrics for free. So we use New Relic for metrics, and the canonical logs will contain stuff like timings or number of API calls we make. And then without any extra effort, we can get some nice graphs like this in New Relic. So basically, we're shipping the same data to different systems. Another use case is that you might store the ordinary logs for, let's say, a week or a month, and then canonical logs are those more useful summaries which you might retain for longer. So even though you'll be lacking some detail in the future, you'll still be able to go back and look at how your system has changed over the course of a year, for example. Yeah.
I wanted to share a bit of experience. How did we deal with this distributed with logging of distributed events? So what we found out useful for us is passing over the kind of event UID. So the first time a piece of event or transaction gets logged, so it generates the UID and then it passes it along to the next service as a token to context, so it doesn't have to pass the entire context. And then, even though you don't have like one log entry per event, you have you can query one single transaction from the beginning to an end across the entire chain, like with this token.
Yeah, this would definitely be the case across services. So what I'm showing here is basically limited to a single service doing a single operation, like process one upload or respond to a single API request. But yes, if this service would make a request to another service, then you would want to include something like trace ID so that you can sort of tie together those requests later.
It's and correlation ID.
Different systems have different names for that. But yeah, distributed tracing basically is what you're describing here. To give you a real-world example, this is log from one of our services. And as you can see, it's kind of a wall of text. But you might also notice that there are some stuff that we already covered here, like the canonical entry, some IDs, the duration, and various other information that might be useful. And this also shows that it's not really readily human consumable. Like, you can find information in it if you really need it to, but you would rather use some other system to process it first. So moving on to the lessons learned part, the context here is that I think the first service using structured logging went to production in automation team roughly 3 months ago. And the automation team itself has now converted approximately half of our stuff to structured logging, with the rest of the company following, but we're still in rather early stages. So first of all, the data in the logs is much more useful than just logging text, basically. We already can filter it, use it in filters, use it in search, get some good stuff out of it. As I showed, we can also send the same data to multiple systems, like in our case, New Relic for metrics, and sort of get that for free. And most importantly, there are lots of opportunities when we find the right tooling to use that data with, which brings me to our pain point, basically, which is that tooling is slightly problematic. Searching is really good. But if you want to consume and read the logs, then that's slightly less good. Because most of the tools that we use, they are made for textual logs. And they are made for events that don't contain that much data. And yes?
In particular, we are using elk stack for gathering such logs and metrics. And then in Kibana, you get a representation with a table that, like you select fields or attributes that you're particularly interested in. And then reading a table is quite natural to a human being.
Yeah, but if that table has lots of columns, then that's still something you need to deal with, or but select those attributes then.
Normally you care about a few columns and then you select these ones.
Yeah, that's definitely true. And so, looking into the future, better tooling is one of the things we're looking at now. Be it elk stack, be it something else. We're basically exploring some opportunities there. As we already discussed, we're also looking into distributed tracing. So currently we kind of can correlate what's going on using those upload IDs and verification IDs, but using the proper trace IDs or correlation IDs would make the whole process a bit more straightforward, and depending on the tooling, you would then also get some native view of the call graph basically going on between services. And finally, just adapt all of our services to structured logging so that we can get a single unified view of that within the entire company. So I also included a summary slide as is required. So basically the structured logging is about logging data instead of text with some bits of data embedded into it. You need to sort of change your mindset then to focus on the events and the context that describes those events. The primary consumer now shifts from the human to the machine, and that also means that you can include a lot more context and basically unlock new opportunities depending on the tooling. I also included some links in the slides that you can check out later, and if you have any questions, then I'd be happy to answer them. Thank you.
Will you be upgrading your old logs to the machine-readable format?
Yes. You mean the logs which are already stored?
Yeah.
No.
What will happen to old logs?
The old logs, we will just hope that we won't need them again.
They will remain old.
Yep.
How much effort do you put into complying with GDPR, the data privacy regulation, when it comes to logging?
So when it comes to logging, the basic idea is that you don't log personally identifiable information, which is kind of a bad idea anyway. And once you do that, there shouldn't be any further compliance issues.
Well, yeah, the problem is that this definition is quite broad. For example, the IP address is specifically mentioned in the regulation, but also if, for example, location data plus timestamp together uniquely identifies a person, that becomes personal data.
I would include location and IP address in this PII definition. So basically, whatever data the user sends to us, we don't want to log those. We want to log, let's say, decisions that we make. The IDs, we can use those IDs later to look up the specific data that came from the user, but you shouldn't add them to the logs.
So, answering to this question, you can kind of, forward it to New Relic or AppSign or whatever you are using. They do that for you, and then you don't have to comply, and then you kind of get away with it.
But then how do you comply with the data deletion?
You don't. I mean, it's not yours; it's theirs.
So I have a question. So you have lots of microservices, right? And then it means like there are different teams doing these microservices. Then you have this common approach of logging. Do you have like common vocabulary or something like that? Like if you talk about photo, then we name it photo, not a picture. If you talk about this, so everyone, like when you search logs, you understand what you have to type in, so you find the relevant information.
We mostly have a common vocabulary, and we're working on like unifying the parts which are not there yet.
So then in this case, when you come to another team and say, okay, now you use these words, so you have to then still cope with this difficult
I think this has been more of a problem when we look at stuff like user interfaces, not so much when we look at databases or logs in this case.
One more question related to PII. I understand the problem. The PII is actually logged in some kind of databases related to particular customers. So if you are finding from logs something, you can somehow get possibility to look back at what was the location that we couldn't match to something or like that.
I don't exactly understand what you mean.
Let's say there is a problem of not detecting three faces from an image which has to have three faces. We probably need to go somewhere back and look at the image.
Yeah, we can definitely do that.
So the private information is stored somewhere but outside of the log files, so log files are safe and the data is somewhere.
Yeah, the log files are safe in that they don't contain PII, and then we have like separate domains, let's say, like database, which does contain personal information, and then we can correlate those with IDs.
Thank you, first of all. What those log processing tools which you're using cannot do for you, but you would expect them to do? How smart they are?
So I think the biggest problem has been that they are not that good in showing a subset of log entries. So for example, we might want to look at them as table, which contains only a couple of columns with information that we find relevant at this moment. Also, what we can't do is like advanced graphing possibilities where we sort of use graphs and drill into the data, adding more and more filters over time, which some tools are capable of doing.
Additional thing. Where is the line when only analysts can process those things and all these tools are not in the game anymore?
I think that personally I feel logging is more related to operational data. So you don't usually at least use them for analytics. You use them to look at specific cases of what has been going on, or perhaps generate metrics, at which point it starts resembling the analytical work more. I hope that answers your question. Anything else? No?
Yes, that would be it.
All right, thank you.
Thank you so much.